Hi students, how are you all of you? This is Madhavi Madam Chemistry. So today we will discuss about the important topic from D and F block elements, and that is from both CBSE class 12 and senior IPE. The important question related to Werner's theory of coordination compounds with suitable examples. Okay, so many times they ask this. What is that? Explain Werner's theory of coordination compounds with suitable examples. Okay, so here for Werner's theory, we will discuss the point wise. So what is first Werner's theory? So Werner's theory, Werner's is one of the scientists. He explained the structure of coordination compounds. Werner's theory. Okay, so Werner's theory, this theory explains the structure of coordination compounds. So Werner's theory majorly explains the structure of coordination compounds. The structure of coordination compounds. What is the meaning of coordination compounds? Means the compounds which are having the coordinate covalent bond, those are called coordination compounds. The structure of coordination compounds explained by the which theory? Werner's theory. Okay. In coordination compounds, the central metal atom shows two types of valencies. So in coordination compounds, we have a central metal atom like this. So CO plus 3. CO plus 3 is a central metal atom. So it has two types of valencies. One is called as primary valency and secondary valency. One is primary valency and secondary valency. So first one we will discuss primary valency. What is primary valency? First point, it is equal to the oxidation number of the central atom. Primary valency equal to the
oxidation number of the central atom. It is satisfied only by the negative ions. Who is that? Primary valency. Primary valency is satisfied only by the negative ions. Okay, so primary valency equals to oxidation number of the central atom and it is satisfied only by the negative ions. Okay, next third point in primary valency, it is ionizable. It is ionizable. It is ionizable. Primary valency is ionizable. It is non-directional. There is no direction for this primary valency. So that's why it is non-directional and it is represented by dotted lines. Okay, so this is about the primary valency. Okay, and the second thing, that is secondary valency. Okay, so secondary valency, primary valency equal to oxidation number and secondary valency is equal to the coordination number of the central atom. Okay, so secondary valency equals to the coordination number. Okay, coordination number of the central atom. Okay, next it is satisfied by negative ions, neutral molecules and radially by positive ions. Means secondary valency is satisfied by negative ions, neutral molecules and radially by positive ions. Okay, whereas the primary valency only negative ions. Secondary valency is satisfied by negative ions, neutral molecules and positive ions. Okay, next one. It is non-ionizable. Which one? Secondary valency. Secondary valency is non-ionizable. Non-ionizable. But this is ionizable. Primary valency is ionizable. And it is directional. Secondary valency is directional. And it is represented by solid lines. Primary valency represented by dotted lines. Whereas secondary valency represented by solid lines. And secondary valency exhibits isomerism. Very, very important. So secondary valency will exhibit isomerism, whereas primary valency will not exhibit isomerism. So explain Werner's theory of coordination compounds. It's suitable example question. Werner's theory majorly explains the structure of coordinate compounds. So in this coordinate compound, central metal has two valencies, primary and secondary. Primary valency equals to oxidation state of the central atom. Secondary valency equals to coordination number of the central atom. And it only satisfied by negative ions, whereas it's satisfied by negative ions, neutral molecules, and radially by positive ions. It is ionizable. It is non-ionizable. It is non-directional. It is directional. It is represented by dotted lines, whereas it is represented by solid lines. And extra point for secondary valency, it exhibits isomerism also. See one example. We can easily understand this example. So here we taken hexaamine cobalt trichloride. Okay, so here we have ammonia, NH3 is there. How many are there? 6. Hexaamine cobalt. First we have to see that the cations. Hexa, 6 are there. 6 ammonia. That's why this is called hexaamine. And central metal atom is cobalt trichloride. Okay, this is anion. Okay, so this is the structure of hexaamine cobalt trichloride. Hexaamine cobalt trichloride. So once you observe the structure, this is the central metal atom. So in this central metal atom has two valencies. One is primary valency and another one is secondary valency. So before already we said that primary valency is equals to oxidation number. So CO plus 3. This is oxidation number of this central metal atom. So primary valency is equals to oxidation state. Okay, so here primary valency means this has 3 valency. Primary plus 3 is the oxidation state.
Primary valency of central metal atom is plus 3. Okay, and here the primary valency is represented by dotted lines. Once see dotted lines. How many are there dotted lines? 3 are there. 1, 2, 3. So what is the primary valency of CO plus 3? 3. Okay, and it is only satisfied by negative ions. Okay, these are the negative ions. Understand ma? And this is ionizable. Minus is there, no one see? Minus is there. Yes or no? This is not having direction. That's why this is primary valency. Whereas in secondary valency is equals to the coordination number. Okay, coordination number means how many ligands are there. Okay, now ligands means which will donate the lone pair of electrons to central metal atom. Here 1, 2, 3, 4, 5, 6. So coordination number means here secondary valency. What is the secondary valency of this hexaimine cobalt 3? 6. Primary valency 3. Okay, and this secondary valency is satisfied by neutral molecules, negative ions, positive ions. Here these are the NH3 is the neutral. Okay, and this is represented with solid lines. Solid lines. Yes or no? Secondary valency is represented by solid lines, whereas primary valency is represented by dotted lines. Okay, once you observe here, this is the structure. So here primary valency of CO is 3. It is satisfied by 3 Cl minus ions. Secondary valency of CO is 6. It is satisfied by 6 NH3 molecules. Shape of complex is octahedral. Once see here, the shape of the complex is octahedral. Octam is 8. Okay, this is very important. I think you understand this Werner's theory of coordination compounds. Do if you like my concept and all my videos, please do like, subscribe. Thank you.